Hello everyone and welcome to this video on the rock types. And for those who are familiar with my channel, welcome back. And for those who are familiar with my channel, you probably remember my last video was on the rock types. That video had a couple issues, mainly the audio was bad. I did not like the audio quality in that video. It was really hard to hear what I was even saying at times, but in that video I went to various different locations and actually had visual examples of the different rock formations. So if you are interested in seeing that video, if you haven't already, it should be popping up in the right hand corner right about now as a tag. So if you're interested, there it is. But on this one I'm making today, again, I'll be covering the different rock types, but it will be much clearer and hopefully easier to understand. So let's get right into it. Alright, so there are three different types of rock. There is igneous rock, sedimentary rock, and metamorphic rock. And if you were to go outside right now and pick up a rock, it would fall into one of those three categories. And these three different categories of rock are all formed in different ways. Igneous rock is formed from molten rock. Sedimentary rock is formed from the lithification of different sedimental layers that compact together. And metamorphic rock is a rock that forms due to intense heat and pressure. And within these three rock types are different subcategories. So, for example, for igneous rocks, it can either be an igneous extrusive or an igneous intrusive, and that all comes down to how the rock was formed. Did the rock cool and solidify deep underground, or did it erupt as a lava from a volcano at the surface? And same goes for metamorphic and sedimentary rock. They all have subcategories within them that kind of separate them out into different types of igneous, metamorphic, or sedimentary rock. Okay, so the first group of rock type I will be talking about is igneous rock. Okay, so there is two different types of igneous rock. You have what is called an intrusive and an extrusive. This one is the extrusive. This one is the intrusive. And the way you tell that is the grain size of the individual minerals. So you can see this one has much of a salt and pepper look. You can see the grain sizes in this one. And in this one, it's very fine grained, and you cannot easily see the individual mineral grains in this one. I mean, you can a little bit. You can see here these white specks. You can see these white specks in the rock. This is the feldspars that are in it. So you can sometimes, but for the most part, it's very fine-grained matrix, as is this is a very coarse-grained. So igneous rocks are, of course, formed from magmas, molten rock, and I will begin to talk about intrusive rock. So this rock, of course, is intrusive, and again, the way you tell that is the very large individual minerals that you can see. And I'm not sure what your guys' knowledge on minerals. I'm sure there's some of you that are familiar with minerals, and there's probably some that aren't. But with this one, you can see these black minerals. They're quite large. They're easy to spot. These look like mostly a mineral called a hornblende, maybe a couple biotites. And then your whiter minerals, those are your felsic minerals. So that'd be like quartz and your feldspars. And again, you can see these minerals quite easily. You don't need any kind of magnifying glass to see them. They stick out, and they're in this mixed matrix. And if you were to look really closely, you would be able to see maybe individual quartz minerals, feldspars, in the rock. Now, there's two, I'll just go on this briefly, but there's two different types of, gradients of intrusive rock. So you'll have more of a felsic composition, and then you'll have more of a mafic. And the difference here is the mineral contents within the rock. So usually a felsic rock will be white, and a mafic rock will be more of a darker rock, as you can see here. And these are both intrusive rocks formed from magma that cooled deep below the Earth's surface. And I think I forgot to mention that, but an intrusive rock is a rock that formed deep below the Earth's surface and cooled slowly over thousands to millions of years, and that's how these large individual grains formed. Again, both of these are intrusive rocks. This is more of like a granite, and this would be probably a diorite intrusive rock. And the way you tell them apart is the different minerals, but that's for another video. Alright, so the next rock type is igneous extrusive rock, and this is magma that has reached the surface and erupted as lava now from a volcano. Now, when lava reaches the surface, it is exposed to air temperature, which allows it to cool much more quickly, which doesn't allow any individual mineral grains to really form. So you get more of a fine-grained matrix. So when looking at these are all extrusive igneous rocks that erupted from a volcano, so these are basically solidified lavas. Okay, so the rock you're looking at here, this is a basalt, and the way you can tell that it's a extrusive igneous rock is, one, you cannot see any individual mineral crystals within the rock. It's very fine-grained. You can also probably see the bubbles, or the holes and cavities in this rock. Those are called vesicles, I think. And those are areas where gases were escaping the rock as it solidified. And that is a very common thing that you see in basaltic rocks. And if I pull it over here, you can see some yellowing, some kind of mineral alteration. Now, another example of a basalt is this one here. This is also a basalt, and this one doesn't have any cavities or holes from gases, but it's very dark, and again, you cannot see any individual minerals in this rock. Since it's dark colored, it is more of course, basalt is mafic. Okay, and then looking at this rock, this is also an extrusive rock. Again, you can't really see the individual minerals, and you can a little bit. You can see these individual feldspars that are in here, and these are feldspars that probably solidified within the volcano's magma chamber, and then when the volcano erupted, these got pulled along into the lava. So these feldspars that you see here likely solidified below ground, and then all the rest of it solidified above ground as a lava. And it's more of a gray color, which usually that's typical of more of an intermediate volcanic rock, right in between felsic and mafic in composition. Now, this is also a igneous rock that you might find. This is an interesting one because it is a mixture of fine-grained and large-grained minerals that make up this rock. So this is I believe it's called a porphyritic igneous rock. So what happened here is some of the minerals solidified and crystallized within the magma chamber, and then something happened where the magma either erupted out as a lava or came pretty close to the surface and still allowed it to cool really quickly below ground. So you have these feldspars which cooled deep within the magma chamber. Then the magma moved closer to the surface and solidified more quickly, making more of a fine-grained mineral matrix. So this is either a extrusive or a subvolcanic rock. Alright, so the next group of rock I'll be talking about is sedimentary rock. And these rocks can either be the weathering product of other existing rocks like igneous, metamorphic, and maybe even other sedimentary rocks. Or they can be rocks that were created from organic matter that deposited over a long period of time. So there's two different types, just like igneous rock. There's two different types of sedimentary rock. There's a sedimentary rock we call clastic, and there's a sedimentary rock we call biochemical. So sedimentary rocks, there's various different types and formations, but usually you'll find them as like a hard layered rock like this, But you can see this one has a couple layers in it, but the texture from this rock to this rock is different. And there is no layering in this one, and the textures are way, obviously, different from each other. This one you can see, all the minerals are roughly the same size, and you can see them, they're pretty small. In this one, you've got a mixture of different rocks and fragments. So this would be a well-sorted sedimentary rock, and this would be a poorly sorted sedimentary rock. And this one here is, of course, a sandstone. It's made up of very fine-grained particle-sized minerals, mostly quartz. This one has a lot of feldspars in it. This is more of what they would call a conglomerate. This is formed from, it's a very fine-grained matrix with large pebbles in it, and this fine grain is like kind of like a cement, and it locks together all the large particles, kind of like concrete, but this is like nature's concrete. There's different varieties of conglomerate, and this one is mostly the matrix is mostly white. So this was found near a volcano I went near to, and this is basically ash. This is basically a matrix of ash that forms this conglomerate. So this isn't straight from a volcano. This is more of the weathering product from volcanic rocks in the area. Now, sedimentary rocks can be a little difficult to identify. They're mostly very fine-grained. You're not going to see any mineral grains in them unless you find something like a sandstone and maybe a conglomerate with rock fragments. But for the most part, sedimentary rocks are pretty fine-grained. And there's different ways they form. So these ones likely formed in water. So again, they're sedimentary rocks formed from usually the weathering of rock, or they can be biochemical, and I'll explain that in further detail. But so as layers are eroding off from other rocks, they can get, as they erode or weather over time, the particles can get smaller and smaller until they become super fine-grained, like this rock here. So this could have been like a fine silt that was deposited at the bottom of a lake or ocean. And the sandstone, you can see the grains pretty easily. And this was probably, if near an ocean or lake, this would probably be most commonly found at an ancient shoreline, like a sandy beach, as with this would be deeper out into the depths of the lake or the ocean. And you can see these rocks are pretty similar with this one. This one has a quartz vein in it, but again, I said there was clastic rocks and biochemical, and what that means is biochemical is a rock that was formed from organic material, organic mineral, organic content, and this would be an example of a clastic. This would be a clastic. These two, we can't really tell. They're pretty similar. A biochemical rock, for example, would be a limestone. Limestones form in organic marine environments, and they're formed from basically shelled organisms that make their shells from calcite. Now, a way you can test to see if a rock is clastic or biochemical is with an acid test. So, for the acid test, you'd want to use, ideally, an acid called hydrochloric acid. Now, not too many people probably have that. I know I don't. So another test you could use is home vinegar, but the reaction will not be as intense. And I've already tested it here, and I tried to test it to show you guys, but the reaction is so small with vinegar that it's hard to show on camera. But this one here I tested, and no reaction occurred. So this is a clastic sedimentary rock, likely formed in a deep lake or most likely a deep ocean. And the acid test shows that there is no calcite in the rock at all. Now this rock here, when pouring the vinegar on it, it did react, and if you used hydrochloric acid, it would be fizzing and foaming like crazy from all the calcite that is in this rock, which tells me that this rock is a biochemical rock, and the rock name would be a limestone, and this rock formed in a warm, shallow marine environment, most likely, with shelled organisms, like maybe corals and other animals that make their shells from calcium carbonate. Alright, so the third and final type of rock is metamorphic rock, and this is rock that has changed due to intense heat and pressure. So a metamorphic rock could have started off as an igneous rock, or a sedimentary rock, or another type of metamorphic rock. And as these rocks are exposed to different gradients of heat and pressure, they'll begin to change and the minerals will begin to align. And just like the previous two, igneous and sedimentary rock, metamorphic rock also has two different types of metamorphic rock, and those would be foliated and non-foliated metamorphic rock. And for the most part, every single type of metamorphic rock will be foliated, with a few exceptions. Now, as a rock is exposed to heat and pressure, depending on what kind of rock that is, as the heat and pressure continues to get greater and greater, which usually means it's getting buried deeper into the earth, the rock will slowly change into different forms. For example, the sedimentary rock shale, when exposed to heat and pressure, will first become slate, and then as the heat and pressure continues, it'll change from slate to another kind of rock called phyllite. And if the phyllite is subjected to even more heat and pressure, that'll increase its metamorphism even more, and eventually that phyllite will become something called schist, which is this piece of rock here. And if the schist is exposed to even more heat and pressure, it'll eventually become something called gneiss. And gneiss is the highest grade of metamorphic rock before it starts to melt into an igneous rock. Schist and gneiss would be examples of foliated rock. Now, an example of a non-foliated rock would be this rock here. This is, I believe... So this would be an example of a non-foliated rock. This is quartzite, and this is metamorphic sandstone. So basically, this rock here, the sedimentary rock here, sandstone, when it is subjected to enough heat and pressure, it'll become quartzite. And what's interesting about this rock is, even with increasing heat and pressure, it'll always remain quartzite. And it's the same. It's same with limestone. When limestone is subjected to heat and pressure, limestone will become marble. And no matter how much more heat and pressure you subject that marble to, it'll always remain marble until, of course, if the heat becomes high enough, it'll melt. Now, metamorphic rocks can also be fine-grained, but usually they'll have visible minerals in them. Now, an example of a fine-grained metamorphic rock would be slate, because the shale, the sedimentary shale, just hit its first grade of metamorphism, being slate, and slate and shale look pretty identical. Sometimes you can't tell the difference between them at all, and you'll need a chemical analysis of the rock to see if anything's changed. But anything higher than slate, it's pretty easy to tell. Like phyllite has a sheen to it. It has kind of a shine, and that's from the mica minerals becoming larger. And this is a chunk of gneiss rock. This is metamorphic. And you can see the individual mineral grains in this, kind of like an igneous rock, but it's not an igneous rock. And it can sometimes be hard to tell because metamorphic rock and igneous rocks can be made up of the same mineral content. You just have to be able to identify how those minerals are aligned. And usually a metamorphic rock, like gneiss in particular and schist, they'll be foliated, so the minerals will become aligned and they'll have different layers, kind of like a sedimentary rock. Now, looking at this rock here, I can see there's some garnets in here that grew. And this is a garnet gneiss that I recovered not far from my location. I can see a little bit of feldspars in here, but lots of mafic minerals, mainly like hornblende. Now, this is a schist, and you can see It is loaded with tons of microminerals. It has a really nice shine to it, and there's no layering going on, so I know it's not a gneiss. Gneiss usually is banded, so you'll see lots of layering going on, but since this is just kind of a grainy texture, I know it's a schist. Alright, so this concludes the video on the rock types. So hopefully now you'll be able to identify a rock type on your own, and if not, at least hopefully you know now that there are 3 different types of rocks. So eventually I'll be making more videos like this in the future, but they'll go more in depth slowly over time. It's part of a video series I'm starting where I teach you guys geology. So eventually I'll have more videos on the rock types, looking more into the individual type of rock. So we'll go more in depth on igneous, sedimentary, and metamorphic. We'll look on how they form and what their geological setting is, what characteristics they have, and so on and so forth. Alright, so with that, this concludes today's video. I hope you all enjoyed the video and hopefully learned something new. I hope to make another one as soon as I can, and until then, I'll see you all later. Take care.